Good morning, ladies and gentlemen. Welcome to the second video on normal distributions, this one with standard normal distributions. Standard normal distributions, or standard normal scores, or Z-scores, are quite literally how we compare apples with oranges in statistics. For an example, little Johnny scored 15 in maths methods and 17 in biology, both out of 20. Which should he do better? Now you might think, well, biology because it's a higher score. But remember, quite often we grade relative to the mean, and this is effectively how SACE does it. You look at where the average student is and how far above or below the average student you are. So, what if maths is distributed normally with a mean of 13 and standard deviation of 1, and biology 16 standard deviation of 1? Now which should you do better in? Well, he's done better in both. He's done well in both because he's above both. However, in maths, he is 2 standard deviations above. In biology, he is only 1 standard deviation above. So, relative to the rest of the cohort, in mathematics, he's actually outscored his score in biology. And that is odd in that we have to compare them both to normal distribution and see how far above or below the mean they are in order to make a fair comparison. And this is what Z-scores let us do. Clearly the numbers aren't always going to work out that well with a 1 there to let us see this that clearly. So what we do is we can convert his scores to Z-scores. Every X distribution can be transformed into a standard normal distribution using Z equals X take mu over standard deviation. So, apologies, up the way. In maths, his score was 15. We take away the mean, which is 13 over 1 equals 2. In biology, his score was 17. We take away the mean for the biology over 1, which is 1. What this number indicates is the number of standard deviations above or below the mean. He is 2 standard deviations above the mean in maths, 1 above in biology. Now note, if he had scored 15 in biology, his score would look like 15 takes 16 on 1 equals -1, which means he would be 1 standard deviation below the mean. Z-scores can be both positive and negative, and all they do is give you an indication of how far away from the mean you are in your distribution. So, hence the scores here. A Z-score of 4.75342, if you think about it on the bell curve, would put you 1, 2, 3, 4 distributions out, which is an infinitesimally small percentage of the population. Hence, 1 in a million are down that far out with a Z-score. Alright, if we transform all the values within a distribution, so not just little Johnny's score, but of everybody's score, and we do that to all of theirs, what we get is a new distribution that is distributed normally with a mean of 0 and a standard deviation of 1. Essentially, all those scores that would have been out of 20 originally are now distributed evenly around the 0, above and below. Alright, and here is our sort of formula we've seen before, but now with the new values of 0 and 1. And note that the Z-scores have exactly the same properties as the original normal distributions in terms of this percentage split we see here. So, just reiterating, if we had a population, say, weights of 100 with standard deviation of 10, once we transform it, now has a mean of 0 and a standard deviation of 1. Alright, so a typical kind of question here would be giving you a number of different distributions. Say, salary distributions, where this is monthly salary in different countries, standard deviation, all put down to US dollars. If you earn $1,000 a month, what percentile in terms of income would you be in for each country? So here, you really need to figure out, well, how far up and down you are. You can create a Z-score for every country. And you can sort of see that with $1,000 a month, you're going to be below average, a little bit below for Brazil, considerably below for United States and Kuwait, considerably above for Slovakia, and even more so for China. This data must be quite old. Apologies. Extremely old. Why might this be a reasonable approach? This approach only works if things are normally distributed. And typically, income, you probably argue, wouldn't be normally distributed. It tends to be there is a tail, and you can imagine the income looks something like this, where quite a lot of people have not much, then there is a peak, and then there's some people who are really very rich up there, and no one's negative. So it's perhaps a crude estimation of normal at best for distribution, for income distribution. Alright, try to make this short. Hopefully that gives you a basic idea of what a z-score calculation does. Basically, that is what you need to know, and then Johnny's example is a good one. Alright, thank you very much.